Intercepts first. We'll do y-intercept because that's the easiest. Y-intercept is when x is 0, so you just plug 0 into your equation. What do you get? You're going to get 0, right? Because you put 0 in, you're going to get negative 0 squared over 0 minus 1, so you get 0. So your y-intercept is 0, 0. Congratulations, you got a half mark. 0.5 out of 10. You're on a roll. Are we good with that? Okay. Now we're going to do x-intercepts. Yes, it is, Vina. So x-intercepts are when y is 0. So if you put y is equal to 0 into here, the only thing, if you were in my math 12 class, when we did y-intercepts, the only thing you have to look at is what? The numerator, right? The denominator is irrelevant. Because essentially, I mean, this is what you're solving. If you multiply that up, it goes away. So you only have to look at what makes the numerator 0. In this case, it's 0. So 0, 0 again. So that means the graph goes through the origin. That's what it means. All right, we're 1 out of 10, people. Pretty good, 10%. All right. Now we'll do asymptotes. All right. Asymptotes. The vertical asymptotes are what? How do you find them? What makes the denominator equal to 0? In this case, 1. Peoples, 1.5 out of 10. 15%, not bad. Okay. Horizontal. Is there a horizontal? Why? It's top heavy. The numerator has a higher degree than the denominator, so none. Therefore, we have a slant or oblique asymptote. What if the bottom's bigger? The bottom's bigger, it's 0. Yeah. All right. Yeah. Some sort of asymptote. All right, slant or oblique, how do we find it? Now, yes, long division works every time. For those of you that like synthetic, could you use synthetic on this one? Yes. Because it's a linear denominator, right? So I don't care if you do long or synthetic. I'm going to do long division to be consistent with what I've done. Sorry? Can we buy the long division? No, you can't buy everything. Otherwise, you're going to get 1.5 out of 10. Okay, no. If we bought maybe 7.5. All right, so I'm going to go x minus 1 into negative x squared. Okay, how many times, what do you multiply x by to get to negative x squared? Negative x. So then I get negative x squared, negative x. Subtract them. You could put a 0 there to hold the place. 0 minus negative x is x? No, it's... Positive x. Oh, thank you. Yeah, because it's, negative. Thank you. So then it's negative x. There we go. Whew. How many times, what do you multiply x by to get negative x? Negative 1. And then you can do it again. You get negative x plus 1. That'd be plus 0. But do we care about the remainder? We don't, but we'll do it anyway.
If we don't show that on the test.
If you should, well, you should be able to. I don't care what the remainder is, but you have to keep going until you get to the remainder, right? So at this point, you can stop. What is our slanted or oblique asymptote? It's the quotient, right? Negative x minus 1. So the asymptote y is equal to negative x minus 1. There we go. What do you think? What's that, a mark? Another half mark? So we're at 2? 2 out of 10.
Oh my goodness. We had it. Now we're at 20%.
Well, we started at 0.5 or 5%. Okay, that's all the stuff you can do without calculus. Now we got to do calculus. So we have to find the critical numbers. How do you find the crits? Derive it. What rule are we going to have to use on this? Quotient. Quotient or product, it doesn't matter. You'll end up in the same spot. But I'm going to use quotient. You're going to need to simplify it though. All right? So here we go. Quotient rule. So the crits. I should do this in a different color. What color should I do it in? Blue. All right, here we go. Y prime equals either one of those would work. Thank you very much. Oh, no, you're on spare. Thanks. What? X bracket 2 minus. Yeah, that's fine. It's all the same. Yeah. Okay. So we've got the first derivative. Everybody agree with it? Yeah. Okay. We have to find the critical numbers. Critical numbers are what make it equal to or undefined. So our crits. What make it equal to 0 or what make the numerator 0? What makes the numerator 0? What makes this 0? 0. What makes this 0? 2. Let's say when it's factored like this, it's easy to see, right? So 0 and 2. And what makes it undefined? What makes it undefined? Just 1, not positive or negative 1. Because it's not x squared minus 1.
Well, I thought
if you put negative 1 in there, you're going to negative 1 minus 1 is negative 2, right? So it's still defined. Only one positive 1 will make it undefined.
But if you were to if you were to use the square root.
But what are you square rooting?
Or no, not square root. Like if you were to raise to the power of 2.
Huh?
No, never mind.
Because just as an aside, if I said what makes it undefined, you would just go x minus 1 all squared can equal 0, right? That would make it undefined. So if you square root both sides, that's the correct move. But if you square root 0, it's just 0, right? So you only get one answer. Okay, so we've got our crits. There's our crits. Congratulations, you got another mark. What are we up to now? 3? 3.5 out of 35%. Good job, peoples. All right, what's the next step? Second derivative. Go. Now, actually, hang on before you do it. Don't use this one to do second derivative. Why? Because it's factored, right? You'd have to do the derivative of the top would be product rule combined with the quotient rule. Use this one because it's a little easier to do this top derivative, right? Does that make sense? Okay, second derivative, go. I'll meet you on the other side. I.e., when we have the answer. And simplify as far as you go because it does simplify nicely. Remember, this is calculus 12, so everything's sort of rigged. What color? Pink. Do I even have a pink? I have plum. Whoever said pink. What's up? You done?
Yeah.
Okay, thank you. All right. It does simplify nicely. Are people done? There's the answer. -2 over x minus 2 all cubed. So does everybody understand? Listen, might as well go through this. Everybody understand this first line here? Oh, x minus 1. Sorry, why is it? Thank you. I changed it. There we go. X minus 1. Okay. So then I factored out an x minus 1. So that made that reduced to power 1. That one's gone. And then I just have this 2 in front of it. Expand this. You get this line. Everything cancels except for the -2. I'll do it after product. Are we good? No? I'm going to pause the video. Just do it on a separate piece of paper. Or here, you want another one? What do I do with them? Here. Let's do it on the back of that. Okay. We have the second derivative. What is the second derivative? What are we looking for with the second derivative? Concavity. So we're looking for things that make the second derivative equal to 0 or undefined. There's only one point. X is equal to 1, right? So we call these the PPOI. The possible points of inflection is x equals 1. All right. Now we have all our information. Well, we don't have all of it. Now we've got to test the intervals to see where we're positive and negative and all that kind of stuff. But you got another mark for doing this. Congratulations. We are now at 4.5 out of 10. Almost a pass. Okay. This is your next step. I make a number line. Now, how you want to do it is your choice. I put the first derivative up top, and I put the second derivative, which I'm going to do in a different color, on the bottom. All right. Then, for the first derivative, on the number line, you mark your critical points. Okay? So what are our critical points? 0, 2, 1, or 0, 1, 2. Mark those on the line. I'm going to do it in green. 0, 1, and 2. Oh, I should put 0 over to the 0, 1, 2. For the second derivative, you mark your possible points of inflection. Now, it's the same as the critical points, so we don't have to put any other numbers up there. But sometimes you'll have different points that you would put on there. Okay? All right. Now we have to test all the intervals. We're just testing to see where it's positive and negative, i.e. concave up, concave down, increasing and decreasing. Okay? Here we go. Blue. All right. So using the first derivative, see if I can squeeze this onto one page. There we go. All right. We're going to do the green stuff first derivative. On the interval from negative infinity, way out here, to 0. I need a point. You can pick any point you want. What would be a nice easy point? -1.
Negative.
We're putting it into the first derivative. So into, get that little thing off there. There we go. All right. So I'm putting -1 into this. So first of all, is the bottom ever negative?
No. Yeah.
No. No, because it's being squared, right? So I don't even have to worry about the bottom. Bottom's always positive. Look at the top. If I put -1 into x here, is it going to be positive or negative? Positive, right? If I put -1 into there, am I getting a positive or negative?
Negative.
So that means I have a negative up top, divided by the bottom, which is positive. So the answer is?
Negative.
Negative. If we're negative, first derivative, is the graph going up or down? So we are decreasing. You have to do that for every interval. For the green stuff, just for the first derivative. I'll let you do the rest of them, and then we'll check to make sure before we do second derivative. So you have to do 0 to 1, 1 to 2, 2 to infinity.
Can I get one off the sheet?
I thought I had an extra one. Can you go? Do you know what a photocopy?
Yeah.
Do you know what a photocopier is? Go photocopy that.
I don't know the password.
2240. Are we done? No? We're just doing first derivative. I just want to know where it's positive, negative, i.e. going up, going down. Are we having fun yet, people?
Yeah.
We ready? Does it look like that? Negative, positive, positive, negative.
Yeah.
Decreasing, increasing, increasing, decreasing. Yeah? Okay. Now we have to do the same for second derivative, but there's only one possible point of inflection for the second derivative, right? It's 1. So that's the splitting point. So you only have to test something on this side of 1 and on this side of 1. So what would be the easiest point to test if you're using this side of 1? 0. So if I put 0 into the second derivative, what happens? 0 minus 1 is? -1. Negative cubed is? Negative. A negative divided by a negative is a?
Positive.
Which means we are?
No.
Concave up. So we know the graph is like smiley face. You don't have to draw the smiley face. I don't really care if you write it. I'm just concave up, well, up, happy face. Then you got to test the other side of 1. So 2. What's it going to be? It's going to be negative, which is concave down. Can't write concave down.
How many marks are we at?
We are at, so you do that table. I'm going to say we're at 8. I'll break it down afterwards. I'll break down all the marks after. I'm just guessing as I'm saying it, but I think we're at 8 because sketching the graph is 2 marks.
Oh, really?
So now the only thing we have left is to sketch the graph. We're 8 out of 10. That's 80%. That's a B.
That's all I need.
Are we going to go for 100?
Yeah.
All right, now we're going to sketch the graph. You want to try and do it on your own?
No.
Okay. Oh. Here we go. I don't have a graph, so I'm going to wing it. You have a graph on the backside. I do not. Okay. So on your graph, we have to mark, pick the easy points to mark first. That's all the stuff we did right at the beginning. Intercepts, x and y, is at the origin, 0, 0. Vertical asymptote, x is equal to 1. I wish I had a graph. Give me a sec here. I can actually upload a graph. That'll be easier. All right. So we got our vertical asymptote marked. We got our x and y intercept marked, which is just the origin in this case. We can now mark the slant asymptote. The slant asymptote is y is equal to negative x minus 1. That is a linear line, right? Which has a y-intercept of negative 1, which is right there. Actually, I should do this in a different color. Negative 1, which is right there. And it has a slope of negative 1. So we go down 1 and over 1. This is our slant asymptote. Go away. What? Hello. Give me 1 sec to draw it. Negative 1 over 1, right? M is negative 1, which is rise over run, right? So you go down 1 over 1. There is your slant asymptote. Oh, I will. That is not your slant asymptote because it didn't go through the y-intercept that I marked, which is negative 1. Let's go with this. All right. Okay. Do we remember mx plus b? B is your y-intercept, so negative 1. M is your slope, rise over the run, right? Negative 1 is rise over the run, so it's negative 1 over 1. So negative rise means we go down 1, and a positive run means we go to the right 1. There we go. Now I can draw it. There we go. All right. Okay. So we have a vertical, we have a slant, we have a point that we go through, which is the y-intercept right there. We can start sketching this graph. So, all right. What is, so we look at the table that we did, this table right here. We are concave up all the way from negative infinity to 1, and we are decreasing. So we have a min at 0. Does everybody see that, essentially? We're decreasing and increasing. There's a min there. Okay? So, if we go back to the graph, we are coming down, decreasing. This is our min right there. You can't touch the asymptotes, right? And we're concave up. So there's the graph. It's getting close. This is our horizontal, or sorry, our oblique asymptote. And this is the vertical asymptote. That's the only way I can draw that so that it goes through that point and it's still decreasing and then increasing with the concave up. All right.
What if we just plug in values?
That's a lot of values to plug in.
I've done it before.
You could do it. All right. I'm going to look for the calculus, though. All right. The next bit is, what are we doing? We are increasing, then decreasing. So we have a max at 2, and we're concave down over that whole interval, right? Yeah?
If you plug in 1, you find what it has.
If you do, but if you plug in 1 on this graph, you're going to get undefined because it's going to be 0.
Oh yeah, that's not
Whoa. I didn't want that to happen. I don't want ink to shape. There's your graph, people. Yeah, I'm going to do that in a sec. The max. Yeah, I'm going to do that in a sec. All right. That's the general shape. There's one thing that I didn't do. I didn't actually look up what is the value of this point. How do I find that? Plug 2 into the original function to get this value, right? So, f of 2. Literally put 2 into the original function, which is negative 2 over 2 minus 1. What is that? Negative 4. So I didn't mark it quite correctly. I don't really care. If you wanted to mark it correctly, negative 4 would have been right there. So if you wanted to be perfectly accurate, it would be like, but that's okay. So that's how you would find this actual max is at 2, negative 4. Okay? 10 out of 10?
No, I wouldn't. I think you lost down to 8.
8's not bad.
I think you got to the second derivative.
All right. No, you can't go on a break. We'd be getting in trouble. Well, no, I haven't, but apparently there's another teacher that lets people out for 10-minute breaks. Yeah. Okay.